Okay, next up we have David Glazer. He's the CTO at Verily Health, focusing on their precision health platform engineering, and he's here to talk about solving for friction next generation TREs for accelerated discovery.
Thank you. Good still morning. Great to see everybody. I'm going to structure the next 15 minutes as an opportunity. You need me right here? Yes, please. Yeah, I don't stand still well, sorry.
Sorry.
Appreciate it, thank you. So I'm going to structure the next 15 minutes in terms of an opportunity, a challenge, and then a case study of some work that we're working with some partners to try to address. And you know, when I saw the theme of the whole track around acceleration, I immediately snapped back to 3 miles away and several decades ago when I was studying freshman physics. And that the way you get acceleration is you have to have, it's about force and mass, and the way you get acceleration is you reduce friction. So what are the kinds of friction that are in the way of us generating insights from data? And the 3 big categories of friction, and a couple of the previous speakers talked about siloed data and how siloed data gets in the way of being able to reason across it all. There's friction around policy, friction around the science itself, the data, the insights, and then there's friction around the technology, the plumbing that makes it possible. So the opportunity is that we have more available, relevant, health-relevant, biology-relevant data than we've ever had before. This is continuing to grow. Any curve on any modality, on any dimension of longitudinality of data points, on N of populations, on the number of different measures that are available, they keep growing. We have data from millions of people, and that's continuing to grow. Awesome, but it's hard to use that data collectively. It's hard to put it together. This is from a paper that we put out together with the leaders of UK Biobank and all of us and Genomics England and Our Future Health, you know, few of those people who are contributing to the opportunity, but at the same time recognizing the challenge. And the state of the world right now is messy for people who want to work with all that data. This doesn't even include the internal data the previous speakers talked about, but most people who want to do analysis, they want to work with data that's accessed via different tools and different rules in different environments. And what that leads to is, I was at a talk recently where a research fellow at one of the top 10 pharma basically said to an audience full of cohort developers, can you guys please get your act together? Why are you making my life so hard? I love your data, but you're making my life hard. I don't mind jumping through hoops. I kind of mind jumping through 10 different hoops to get at 10 different data sets with 10 different sets of rules. That's the friction. And that friction is partly policy, partly science, partly technology, but good news is there's enough data out there that we want to solve this. Bad news is it's still hard. An example, this is the case study, is a project that my team, together with several others, is working on. The NIH put out a call for a SysBio project. SysBio for systems biology. The idea was we have a bunch of data in different silos, and we'd like to make it work better together. The data in this case was the FNIH AMP data. FNIH has created about a dozen of these disease-focused programs over the last decade plus in a bunch of different areas, and every one of those programs has made good choices to solve their problem, to address their mission. They picked the data, they picked the formats, they picked the technology, they picked the policies, and they each did that, and what that resulted in is local success. Each AMP is succeeding at its mission, but this global challenge of it would kind of be nice if you're studying Parkinson's to look at the Alzheimer's data and see, is there anything interesting? Where are there differences? Where is it true that everyone's case is someone else's control? Where is it true there's actually a common pathway and our artificial disease labels are wrong? It would be great to answer questions like that, to study the systems biology. So the goal was, can we take those silos, turn them into semi-permeable membranes, maintain the amount of local control that is needed, but provide the amount of global access that's desired. And the approach that we're taking in this project, which I think is one of many places where the same patterns apply, is on all 3 fronts. So on the policy side, we're doing work to say, where are the data use agreements necessarily different, and where are they just accidentally different, and where could we align them and make it simpler? Where could we potentially say, if any of you have either recently or have kids who have recently applied to college, when I did it, every college was its own application. Then the Common App came up. It was, they were kind of the same. In California, you apply to the UCs, you just check a box. And they charge you a little bit more each time you check the box, but you check a box for whichever college you want to go to. Wouldn't it be nice if the way you applied for access to multiple data sets was checking boxes? So moving in that direction on the policy side. On the science side, every data scientist that I've talked to about a project, you say, tell me about where you spend your time. It's like, well, I had to get access to the data. I had to move the data over here. Then I had to figure out what units it was in. Then I had to convert it. Then I had to wrangle it to be cross-compatible. Then I started science. So we're doing the work here to say, where can we extract common data elements? Where can we use AI to help accelerate that? Where can we create a common format? So once you have permission to access data in different places, you have the ability to actually get to work on it. And then the technology side is lowering the technical friction, the plumbing friction, making it so when a researcher says, I have permission to access data from here, here, and here, and I want to, they can just pick that data and get to work without having to find a different set of tools, different analysis environment for everything. This is a problem that Verily's been working on solving for a bunch of years, and over the years, we found a bunch of common needs, such as the ones I described, and we put together our pre-platform, which is a platform for precision health, meaning that supports the full life cycle of biomedical data. And our platform has these three faces to it that are the ways most people use it to address that life cycle. We have a Refinery solution that helps people take messy data and turn it into research-ready data. We have an exchange to help people discover the tools, models, and data that they want to work on so they can find and check, oh yeah, I want that data set and that data set for this. And then we have Workbench where they put it all to work. So a slide on each of them. This is a case study from our work with the University of Colorado where they had, like everyone, had messy data and worked with us and our Refinery team to turn it into data that allowed them to extract the relevant signals on the relevant populations focused on the disease of interest, finding the biomarkers that they wanted to work on, move that forward. Our exchange solution I talked about for discovery. I'm not going to say much about it now, but if you're interested in more, this QR code, there's a webinar coming up, and you can hear more about how exchange works, either as someone who might have data that you want to make easy for other people to discover and access, or as someone who's looking for an easy way to discover data from multiple sources. I'm going to have a few slides talking about what were the design decisions that we made in Verily Workbench specifically targeted at reducing that friction while maintaining local control. The first is this notion of data collections, where each data provider packages their data into a data collection and defines who has access to it, defines how they want to organize it, packages up their metadata, all the things you need to say. If you think back to all those silos, each silo would be represented as a data collection controlled by the data owner. But then since all the data collections have some common interfaces, you're able to reason across them. The very important part of data collections is it's your data, it's your rules. So anyone who sets up a data collection can add policies to that data collection. And then the system, we call computational governance, has to label the approach. The system enforces those policies so that you as a data provider don't have to worry, and you as a data consumer don't have to wonder if you're coloring within the lines. That's the system's job. So there might be a data set that says, hey, my data is only allowed to be accessed in this geo region or that region. There might be a data set that says, you can download me, another data set that says, you can't download me. Well, the system says if you're working on both data sets, if one of them says no download, you can't download. So the system takes care of enforcing those policies for you. An example of that is the All of Us research program is using this same platform, Verily Workbench, and it has set up a set of data collections with a set of All of Us specific policies. A researcher who wants to use Workbench to access All of Us within that silo goes ahead and does that, has access to data from 500,000 plus people, 500,000 plus genomes, 600,000 plus people, 20,000 researchers have registered over time, they can do that. If they also want to cross-analyze that data with data from some other data set, they can use the same environment and know that the correct policies are being enforced, and they're able to, again, follow the rules of each owner, reducing the friction to get to the science and analysis. And Workbench, in order to do that, had to provide flexibility on a bunch of dimensions. We support people who want to work with Google Cloud and people who want to work with AWS. Most people pick one. Some choose both and say, I want to mirror my data to get maximum reach. But it's seamless to a researcher. You just pick the environment that your data's in. The slides are disappearing on me. There we go. So, summarizing, I walked through at the bottom middle there the idea of taking those silos of data from the dozen or so different AMPs that FNIH has generated and reducing the barriers between them while still keeping local control. That's a global opportunity. That's not limited to, hey, just those 12 data sets. These are some of the continuing growth of relevant biomedical data out there. Hits all the same challenges of great data, hard to work on together. The same approaches that we've taken with SysBio to reduce friction, which will accelerate insights, are the approaches that we are starting to see people taking across the global landscape of data, which is becoming abundant. So thank you, and happy to take any questions.
We have 4 minutes for questions. No question?
Thank you. Great talk. You mentioned multi-cloud. For multi-cloud, we've seen AWS and GCP. Have you created like an abstraction layer to unify the two? What's the nature in terms of infrastructure of what you call the Workbench? Is it a VM? Is it a container? Or is it more complex? What happens if the researcher needs an HPC cluster?
Yeah, no, great question. So there's several pieces. Let me start. So first, a couple of principles. One principle is cloud agnostic, and one principle is cloud transparent. And they're slightly in tension, but that's for good reason. So the first around cloud agnostic is we try to provide a common researcher experience where a researcher doesn't have to think about it. So a researcher comes in, they create a workspace. That's an abstraction that we provide. It's exactly what it sounds like. In a workspace, you can say, oh, I want to pull in data from these data collections. Great. Still not thinking about what cloud I'm on. You are on a cloud, but you're not thinking about it. You then say, oh, I want to run Jupyter Lab or any of the dozen of apps that we have built in or custom apps. You say, I want to run Jupyter Lab. We spin up a virtual machine. You don't care what cloud it's on. I care, because I had to figure out how to spin up a machine on this cloud versus that cloud. Spin up a virtual machine, pop up a new tab in your browser, run Jupyter Lab on it. You're now running Jupyter Lab. So everything there is completely cloud agnostic. Same if you want to run a Nextflow or a Whittle workflow, completely cloud agnostic. We have a UI. You can think science, you can think data, you can think policies, and you can do your work. And that's as it should be, right? It's like, I have no idea who generated the electricity behind the lights when I flipped the switch, nor should I. Cloud transparent, though, means that sometimes you care. Sometimes you have a reserved GPU available because you've paid a lot of money to get reserved GPU capacity on Google Cloud, and you want to use that for the training run that you're running inside. So for that, we have cloud transparency where we get out of the way and say, oh, you want to configure the VM? We'll pop up a config dialog that's very much cloud specific. Oh, you want to pick the region? We'll let you pick a region, but those regions are obviously very cloud specific. Oh, you have an agreement where you have discount pricing for volume with this cloud? Great, bring your pricing with you. And cloud transparent, we let you use your pricing. So, so it's both, where the choice is where can we abstract the cloud away and make it completely invisible to the researcher, and where might the researcher care, and there we try to get out of the way and be completely transparent.
quick follow-up question. So now, suppose that a VM or Jupyter Notebook is not all. The infrastructure needed is more complex. Then it requires Terraform, or it requires something that is not cloud agnostic or nor cloud transparent. That's what, and now the other aspect is the templating thing. So the fact that people will tap into a catalog of predefined templates that you have provisioned for them. Many researchers have, as some part of the work they do is a bit like a hacker. They play with things, they try things, they would like to snapshot and potentially also to share with other researchers. So how much flexibility do you give them? Do they need to refer to you each time there is a new Workbench?
No, I don't have enough time to answer. But let me give you a motivating example that drove our approach to be able to say yes to that question. So with the All of Us research program, we started supporting that program 10 years ago, and when we first launched the Workbench, probably about 7 years ago, was when the first data was available, and we started asking people, what do you think? You know, we asked researchers, how's this tool working for you? And we got two sets of feedback. We got one set of feedback saying, you know, I love the idea, but why are you making me write code? And the other set of feedback was, why are you getting in the way? I just want to write some code. And obviously both were correct, but it was a bimodal audience, and the answer was it was not a one-size-fits-all. And we said, okay, how can we help both audiences? For the bio-forward audience that was not particularly tech-savvy, we said for them, what can we do that's point and click, right? You're not going to have full flexibility because you don't want it, but where can we give you a graphical explore, discover, pick a cohort, send it off, right? Where can we do that? And we have a lot there, and we have examples of high school students publishing papers using the tools, right? It's like, that's awesome. For the tech-forward people, we said, you know, how can we provide an environment where not only can you run a set of built-in apps, but you can bring your own apps? And so, you know, on the drop-down in the UI, that's launch an app and it has Jupyter Lab in our studio, and it also has custom. And custom is, if you know what a dev container is, build a dev container, stick some Docker containers in it, wrap it with what you want, expose it on a port, tell us where it is, and launch it. And now you're running any arbitrary analysis app you've got. Could be a proprietary one, could be a public one. You're doing that. Oh, your app actually needs to run on a cluster? Fine, that VM config thing, click one more, you can say, I want a Spark cluster behind the scenes, and we'll spin that all up for you. So when you click that button, instead of just a VM with Jupyter Lab, it's a cluster of VMs with whatever software you've decided to preload onto them. And then obviously, if you're using batch workflows, you're probably using either Nextflow or Whittle to run those workflows. That provides an awful lot of scale and flexibility, and you can build your own. So those are the sets of things. We're never done, but those are the sets of ways we say yes to the people who want to go deeper.
Thank you so much.
All right.